Film has been around since the 1800s. The first motion picture camera shook the world, and now we have big blockbusters. What people don't realize is that math is in the production of film itself, why the camera works, and how film can look so good if done right. Math is first behind the actual camera. SLR cameras in particular have lenses that detach to allow for better picture, light, distance, etc. These things are constructed through the aperture, shutter speed, focal length, ISO, f-stop, exposure, and so on. The aperture is the diameter of the lens. While the aperture is measured by the diameter of the lens or mirror, light that goes through is measured by the area. The area of a circle equals pi times by radius squared, which is how you can calculate the aperture. That controls the amount of light that reaches the sensor. The larger the aperture or diameter, the more light is let in. Many other things on the camera work in that way, such as the shutter speed. Common shutter speeds are 1 in 1000, 1 in 500, 1 in 250, 1 in 125, and so on. The shutter speeds form a geometric sequence. Moving from 1/1000th of a second to 1 second, it increases the shutter speed and increases the time and the amount of light hitting the film by a factor of 2. The common ratio is hence 2. Shutter speed dials often use just the denominator instead of the whole fraction. The fraction of the second is how long the camera lets light in. The f-stop is the ratio between the diameter of the aperture of the lens and the focal length of the lens. The typical sequence is 1.4, 2, 2.8, 4, 5.6, 8, 11, 16, 22. To get the same amount of light in a different lens, you need to get a lens with 4 times the area. So, 4 You use the equation on how to find the circumference, pi radius squared, taking the square root of both sides, r approximately equals 14 millimeters, or diameter equals 2r, or 28 millimeters. Therefore, to get the same amount of light as a 28 millimeter focal length lens with a diameter of 44 millimeters, you need a 55 millimeter lens with about twice the diameter, or 28 millimeters. Basically, this also controls the amount of light. The lower the f-stop, the brighter the shot. Now on to the ISO. ISO stands for International Standards Organization. The higher the ISO, the brighter the shot will be, because the higher the ISO, the more sensitive it is to light. The sequence is a geometric ratio as well, and typically goes 100, 200, 400, 800, 1600, 3200, and 6400. The f-stop and the ISO can be interchanged to get the best image. The best thing to do is to get the ISO as low as you can by making the f-stop go lower, but you have to watch out for it not being too dark, because it won't matter how crisp the image is if you can't fully see anything. Now, in film you want the best picture. Mathematics is the way that it can look so good. Coordinate geometry is the point of a variable on a grid. In film, it is where the subject is on the screen. The location of points in this way was proposed by French mathematician René Descartes in the early 17th century. He proposed further that curves and lines could be created by equations using this technique, which actually was the first to link algebra and geometry. In coordinate geometry, points are placed on a coordinate plane. This is a grid that allows for you to plot points, lines, and curves. It has 2 scales called the x-axis and the y-axis that form a right angle. This relates to the rule of thirds. You can cut the screen into a 3x3 grid. You can place subjects such as characters on the right line and then one on the left facing each other, and put their eye lines on the horizontal lines is the best way to go. You can place other objects on those lines as well. You can go from a shot like this to 2 separate shots of the person, and you will keep these people on those lines. Cutting the image into a 3x3 grid allows for a more dynamic image than just cutting it in half. Because like I said, you can place one subject on the right line and one subject on the left line, instead of on center, because it is much more pleasing to the eye to have something off center than directly on center, and the grid allows for it to still be a balanced image. Placing eye lines and other objects on the intersections of the lines allows for a nicely balanced image as well. This grid is also useful with the 180-degree rule. The 180-degree rule is if you have a room, this is a bird's eye view, and you have somebody here, there is an imaginary line going through the 2 people. You can place the camera either on this side of the line or this side of the line during the scene. But if you switch the line onto this line when you started with it on this side, then it will completely swap the image, and somebody that was on the left side of the screen will now be on the right side of the screen. As in, it will completely flip the image. This is called a reverse angle. Doing this distracts the reader and completely pulls them out of immersion. But mathematics isn't just in the camera, it's also behind the scenes in, of course, costumes and set measurements and budgeting. Accountants have to calculate how much it will cost to produce a film and how much they can afford to spend. Budget calculations are split into 4 main parts. Above the line, producers, actors, directors, and writers. Below the line, hairdressers, costumers, assistant director, cameramen, etc. Post-production, editing and visual effects, and other, and in this category you can fit things like insurance and completion bonds. The template that is used ends up being around 60 pages or more, and it is detailed to the dollar. This includes the account number, the description of what the cost of that thing or person is, the amount of units worked or used, what the unit is in terms of hours, days, or weeks, and the rate, what the company is willing to pay or what the person and suppliers charge. And of course the subtotal and total. As filming can be unpredictable, it often goes longer than planned. So in that situation, the supplier or person will get paid an extra 10% of what their rate is, because the budget is created before filming occurs. As you now know, mathematics is behind film. But you don't need to know the math behind the camera and all the equations behind it to film. But it is always there.